We are now looking at complex number tutorial 9b, question 12. Question 12 has two parts, part A and part B. Let us first attempt part A. Part A gives us two complex numbers z and w such that z equals to 1 plus ip and w equals to 1 plus iq. Please take note that the condition such that p and q are real and p is positive. The question gives us z multiplied by w equals to 3 minus 4i. So it is clear to us that we will have to first find out what z multiplied w gives us. So we will substitute z, which is 1 plus ip, multiplied by w, which is 1 plus iq. Let's perform the expansion. We will get 1 plus iq plus ip minus pq. The next step that we have to perform is to regroup the real and the imaginary part. So in this case, our real part is 1 minus pq. As of our imaginary part, it is equals to p plus q. Over here, it is clear to us that we shall now compare the real and the imaginary part, and that leads us to getting 1 minus pq equals to 3. That will be our first equation. And p plus q equals to negative 4. And that is our second equation. These two equations will prompt us to solve them simultaneously. So we can say from equation 2, we set p the subject. So it is equals to negative 4 minus q. And we call this equation 3. Then next, we will substitute equation 3 into equation 1. So upon substitution, we will get 1 minus p. Your q will be substituted. We are now looking at complex number tutorial 9b, question 12. Question 12 has two parts, part A and part B. Let us now attempt part A. Part A gives us two complex numbers z and w, where z is equals to 1 plus ip and w is equals to 1 plus iq. Condition is that p and q are both real, and in particular your p is positive. Next, the question tells us that z multiplied by w is equals to 3 minus 4i. And since the question has given us the individual z and w, we shall now perform substitution and then we expand. So we get 1 plus iq plus ip minus pq. And the next step that we should do is to regroup the terms such that the real and the imaginary parts are grouped accordingly. So the real part in this case, we have 1 minus pq. As for the imaginary part, we have p plus q. It is now clear to us that we will have to compare the real part and the imaginary part against the 3 minus 4i the question gives us. And with that, we are able to come up with two equations. For the real part, it says 1 minus pq equals to 3. That will be our first equation. And for the imaginary part, p plus q shall equals to negative 4. And that is our second equation. These two equations will now prompt us to solve them simultaneously. So one of the possible approaches is that from equation 2, you make p the subject. So p equals to negative 4 minus q. And you name this equation 3. So subsequently, you can now sub equation 3 into equation 1. So your equation 1 now says 1 minus p times q. So negative 4 minus q times a q equals to a 3. It is clear to us that we are soon coming to an quadratic equation. So we expand. So we get 1 plus 4q plus q squared equals to 3, which then simplified to q squared plus 4q minus 2 equals to 0. If this quadratic equation can't be factorized, we shall now apply our quadratic formula. So quadratic formula says q equals to negative 4 plus minus square root of your 4 square minus 4 times 1 times negative 2 whole thing divided by 2. And you get negative 4 plus minus. Inside your square root, you are looking at 4 square plus an 8. So it's 16 plus 8, so you get a 24 divided by 2. And since square root 24 can be simplified, so therefore we can get 2 square root 6 divided by 2, and therefore at this moment our q has two values, negative 2 plus minus of square root 6. So we shall now use each of these q value to find the corresponding value of p. But bear in mind, because question says the p has to be positive, we later will get to reject one set of values. So suppose we now set q to be equals to negative 2 plus square root 6. Therefore, from our equation 3, we can see that p equals to a negative 4 minus a q will then give us a negative 2 minus a square root 6. And this clearly is not the answer that we want. So therefore, we will reject this set of values. Next, we will test with q equals to negative 2 minus square root 6. So when your q is equal to this value, again from equation 3, your p says negative 4 minus the q. And in this case, we get a negative 2 plus a square root of 6. And this is greater than 0. So with that, we have found out the exact value of p and q, and that concludes the first part of question 12. Let's now proceed on to question 12 part B. Question 12 part B gives us a complex number of a equals to 1 plus I square root 3, and the question wants us to use the Mervel's theorem to find out the value of this string of expressions in the form of a Cartesian form. Now it is clear to us that we are not going to substitute the a into every single term to find the final answer, because by doing so we are not applying the De Morgan's theorem. So therefore, in order to apply the De Morgan's theorem, we will then have to rely on our complex number a to find its modulus, in this case which is a 2, and its argument of a, in this case it is a pi over 3 or 60 degrees. So with that, we can say that our complex number a can now be represented in either trigo form or in exponential form. So whichever form this a takes, it all depends on how we can now make sense of this string of values. 1 plus a squared plus a cubed plus all the way to a to the power of 9 seems to suggest to us that we are now looking at a geometric progression. And this geometric progression suggests to us that the first term is a 1. The common ratio is A. And the total number of terms in this case, there are 10 of them. So at this juncture, what we can do now is we will apply the formula for GP, and we will simplify the summation of these 10 terms to become your A, which is a 1 minus your R, which is your A to the power of 10 over 1 minus A. And it is now clear to you that we have this term A to the power of 10, which then will allow us to apply our De Morgan's theorem to raise the power of A to become A to the power of 10. So judging from the complexity of this expression, I would then say that the best choice of our A is to be expressed in the form of exponential form. So therefore, we revised our previous step. So our A in this case, if it is written as an exponential form, it is equal to 2e to the power of I times pi over 3. So let's perform the substitutions to this expression. So we will get a 1 minus 2e to the power of I times pi over 3 holding power 10 divided by 1 minus, and for this particular A, we shall be using back the Cartesian form. One of the reasons is that you can see that the 1 and the 1 here will get cancelled, and it definitely will make our manipulation simple. Let's now take a look at the next step. To apply the De Morgan's theorem, we can see that now it is equals to 1 minus 2 to the power of 10 e to the power of I times 10 pi over 3, the whole thing divided by a negative square root 3i. So what shall we be doing right now? At this moment, perhaps we can try to change this particular argument back to its principal domain of the argument. So if the argument is too big, the way that we treat it is that we will constantly minus a 2 pi from it until our argument falls in the principal domain of the argument. And in this case, we will be getting the principal domain of the argument to be a negative 2 pi over 3. So the whole thing still is divided by a negative root 3i. So at this juncture, what we can do now is that since the question wants us to express in the form of x plus iy, which is Cartesian, it is then clear to us that we will have to now work on this exponential term and convert it first to a polar or trigo form. So we will get cosine of negative 2 pi over 3 plus I sine of negative 2 pi over 3. And the whole thing divided by negative square root 3i. And now we can also do another thing, which is to multiply with the conjugate so that we are able to get rid of the item at the denominator. The next thing that you shall be doing now is to try to evaluate the trigo term so that you are able to get the exact value. So in this case, by simplifying everything, on top you will realize that it can be simplified to become 513 plus 512 square root 3i, whole thing divided by negative 3 square root 3i multiplied by its conjugate. And if you were to simplify further, you will get your answer of negative 512 plus 171 square root 3i. And that concludes this question.